this lecture, we will be learning about random access file operations. So what actually random access file operations are? We have learned about standard library functions. All the standard library functions we have covered. From this lecture, we'll be learning about random access file operations. Till now, we have learned like if you want to access any data, that accessing can be done sequential only. Sequential is nothing but the file pointer. If you are considering this is the file pointer, this is the data, and from starting onwards, it has to work. Let us consider it is considering A, B, C, D. Then from first data onwards, that means from the starting onwards, it will be accessing the files in the sequential order, one after the other. Isn't it or not? That means character by character, or record by record, the data will be accessed. But if it is small file, that it is okay. If your data is of small, if your file is having of small data, then accessing the data sequentially is okay. But if you want to access the data from a particular location, let us consider your data consists of 5,000 characters, and you don't want to start accessing from the starting location. You want to access the data from the 3,000 location, 3,000 character. Then instead of starting sequentially from the starting, if you want to access the record from a particular character, then that can be done directly by using your random access file. Random is nothing but you can shift your file pointer from one location to the another location, and from there you can start accessing. That's why it is called as a random access. Sequential access is nothing but from the starting itself we are going to get the value. Okay, so what is the meaning of this random access is you can take your file pointer from one location to the another location. Suppose you are here. From here you can move to here, or from here you can move back, or you can move forward. So that thing you can do easily by using your random access file operations. Okay, so these things which we want to do, whether you want to move forward or backward, or you want to know your current position or not, like that, or suppose if you are in the middle and you want to go back, that how can you do? All these things can be easily done by using your random access functions. And we have 3 random access functions which are supported by our C programming language. They are fseek, ftell and revert. So let us learn theoretically these 3, and I will be showing you one complete program in the last. Okay, so these 3 functions are used to place your file pointer at your required position. So let us see one by one. fseek. Now, what is this fseek is? This function is used to place your file pointer at a particular position. Suppose you know, like I want to place my file position 10 locations from the starting of my file. If you are familiar with that, if you are clear with that information, then that can be easily done by using fseek. Got it, all of you? So the syntax will be like this. You need to use fseek. You need to mention the file pointer whichever you want to use. So file pointer will be specifying the pointer which will be pointing to the particular file. Now next one is displacement. Displacement value tells the integer value. It can be a positive value or a negative value. Now whenever you are giving a positive value, it is nothing but, suppose this is a file, whenever you are giving the displacement value as a positive value, you want to move forward direction, and if you are giving a negative value, you want to move in the backward direction. That is what you need to do. And always this displacement will be of long integer data type. Okay, so when you are giving a long integer value, you need to prefix that one with L, mentioning like it is a long integer value. If you are giving a small value, even if you omit this L also, it will work. But remember here, this displacement value can be a negative value or a positive value. If you give a negative value, then it is nothing but you want to move backward directions from the current position. And if you are giving a positive value, you want to move a forward direction from the current position. And pointer position is nothing but this will set the current position of that file. That is nothing but, if you give, I'll show you the example. The pointer position value can be 0, 1 or 2. Any one of these 3 can be given. If it is 0, it is nothing but from the current position you want to move the displacement times. If you are giving 1, that means if you are giving 0, that means you want to move from the beginning, wherever the file pointer is, we are not bothered about that. But if you are giving the file pointer as 0, that is nothing but from the beginning you want to move displacement side, displacement positions, and if you are giving the value as 1, that is nothing but from the current position wherever you are, you want to move that accordingly as per the displacement value given. If you are giving the value as 2, pointer position 2, it is nothing but irrespective of the file pointer, you want to move from the end of the file. Okay, so only these 3 values can be possible: 0, 1, 2. Okay, so other than 0, 1, 2, you can also give the values like seek. This one is from the beginning. If you write C, you can write like this: seek underscore SCT. Instead of 0, you can also write like this. If you write seek set, then it is nothing but you want to go from the beginning. If you write seek underscore CUR, it is nothing but from the current position you want to write. That means in place of current position, you can write 0 or seek set, or you can write 1 or seek cut, or you can write 2 or seek end. So these values can also be given. Understood? So this is about your fseek. Let us see an example. This is the syntax, and these are the values for the pointer position. So pointer position can be 0, 1, or 2. Now, if you see here some examples, first example is I have written fseek p10 0. Now, what is the meaning of this one? The file is pointed by the pointer p. Okay, and then I want to move 10 positive value given. That means I want to move forward direction 10 bytes, and 0 I have given. What do you mean by 0? 0 is nothing but beginning of the file. That means if this is a file, from the beginning of the file, I want to move 10 bytes in the forward direction. Remember one thing, if you are using 0, don't give a negative value, because from the starting we can't go back. Isn't it or not? That is first example. And the second example you can see fseek P5L1. What do you mean by that one? Suppose sequentially you have worked and you are at this position now. Let us consider. Now, if you are at this position, now P is pointed by this file. 5, that means you want to move forward. 1 is nothing but from the current position. That means from the current position you want to move to the 5 bytes forward direction. Now, whenever you are somewhere not in the beginning, you can use a positive value or a negative value. Why? Because we can move forward and backward direction. Okay, but if you are giving 0 value, you need to be careful. You should not use a negative value. Why? Because we can't move backward. And one more thing, if you are giving a 2 value, what is the meaning of that one? You can give only negative value, because from the end of the file, you can go back only. We can't move forward. So at that time, we need to give only a negative value, not a positive value. This is one more example where from the current position, you want to move 5 bytes backward direction. Okay, so this is about fseek. Now, what is the use of this fseek is, if you want to move your file pointer either forward direction or backward direction, you can, instead of going sequentially, you can randomly place your file pointer, and from there itself you can access your data. Got it? So this is fseek. Next one is ftell. What is the use of this ftell is, it will tell the current position of your file pointer. Suppose, so after some iterations, you want to know where your file pointer is in the file. You don't know the location. So to know the current position of the file pointer, you can use ftell. The syntax is very clear. You need to use ftell, and you need to use a file pointer, the point which is pointed to that particular file. And always it will give you the count value. The integer value will be given, because the file pointer location will be measured by the integer value. FPTR is nothing but a file pointer. Okay. And we have the last random access file operation, which is rewind. What is the use of this rewind is, this rewind is used to bring back your file pointer to your starting location. The name itself is telling rewind. Rewind is nothing but go back to the starting position. Suppose you have your file, you have done some operations, and your file pointer is here now. Now from here you want to go back to the starting position. To do that, you can use fseek also, no problem in that, but you need to know how many characters you have traversed, so that you can give the value in the fseek. But if you don't know the characters, the number of characters you have traversed, then simply you can give rewind, and you can mention the file pointer, then it will be automatically shifted from this pointer to the starting location. That is what rewind. Okay, so to understand these concepts of fseek, ftell and rewind, let us see a simple example. By this example, it will be very clear to you all how we are using this one. Okay, let me open a new file. And what are the things we need to initially do? All the things. Follow carefully, all of you, what I am doing. Okay, I am adding all the header files. And a main method I'm starting. So in the main method, what we need to do, we need to create a file pointer. Let us call that file pointer as f. Now, before working with this one, let me show you the file that I have already created. Let us consider that file is data.txt. In this data.txt, I have simply copied the definition of the computer. So this is the text that is available in this data.txt. Okay. So some data is there in this file. So whenever you are opening the file pointer will be pointing to the first character. Okay. So go back to our program. So we want to open that file. F equal to f open. What is that file? Data.txt. And you want to get the data from the file. So we need to open that file in the read mode. Now, if you are writing like this, now f will be pointing to the first character. Isn't it or not? So before that, let us write our test condition, whether it is, if any problem is there, it has to display like this. So printf /n file does not exist. Right? So we want to write exit 1. Now we will be writing if the file is exist, what we need to do. So what we want to do is, let us do one thing. What we want to do is, initially it is pointing to the first location. Now what I want to do is, I want to read the last 4 characters from the file. Listen carefully what I want to do. I want to read the last 4 characters from the file. That means what I need to do, I need to set my file pointer to the before last 4 characters. To do that one, what I can do, fseek, that means I am setting my file pointer to, what is the first one? I need to tell the file pointer, and I want to move to the from the last. That means your third value should be 2. That means we want to move from the last, and the second value is how many characters? Before that 4. So I am giving -4. Are you understanding what I have done here? I am initially, whenever you are opening your file pointer will be pointing to the starting location. But I want to read the characters from the last 4 characters. That means from the last, set the file pointer f 4 locations in the backward direction. That is what I have done here. Or else you can generalize this one. You can generalize this one asking like how many characters data you want to read from the file. I will generalize this one. Okay. Enter n value. Okay. Okay. Or else enter number of characters you want to read from end. Understood what I am doing? So I am asking the user some value, and that value I want to store it in n. And we need to declare this n. So in n. And then now I can modify this 4 to n. So whatever value you give, that many number of characters from backward direction, it is fixed in your file pointer like that. Okay. Now what I want to do? Now I want to print the data. Printf. Okay. Printf. What we need to do now? Data from file. whatever data we got, that we want to print now. Now to print that one, we need to get the data from the file. So while let us read the data from the file. How to read the data? You all know that one. Let us use get c or f get c, anything you can use. F get c, these things we already learned in the last class. Okay, and I am checking with end of file not equal to eof. I am trying to check and I am printing that value. Printf percentage c comma c. Okay, I think we need to declare this c value. Now what is the meaning, what is the use of this one? For the first time, for the first statement, I have set my file pointer n locations in the backward directions from the end, and from there itself I am reading each and every character till the end of the file, and I am printing that one. Understand all of you? Okay, so let us write first f close of f. Understood? So this is how fseek is used. Let us run this program. Any error is there, that will be printed. What is that? Statement missing semicolon. Here there is no semicolon. Yeah. How many characters you want to read? It is asking. So let me give 5. So it should display 5 values. UTER dot. It has been displayed. Let us check our data file. What are the last 5 characters we have in our program? So the last 5 characters we have in the program is obviously UTER dot. You can check here. These are the last 5 characters we have in our file. So what happened initially, the file pointer, whenever you are opening the file, it will be pointing to the first character. But as we have used fseek, it has shifted from the backward directions, 4 locations, backward direction from the end. So the file pointer will be pointing to this location. So from here, we are reading this one. So if you're one person is asking like L is not required, if you are representing a long int value, then L is required. But here I am writing 4 only, where long int is not required. But if you are using suppose your file is very large enough and you want to give a long integer value, then you need to write L. And there you need to declare that variable as long. Got it? Now this is your program. Now, this is how fseek is used. Now, I will tell you how ftell is used. To understand this one, what I will do is, suppose you are opening the file and you want to know the current position of your file initially. Okay. So, what I can do is, I will be writing printf file pointer immediately after opening the file. So percentage D, and here I am trying to print the value. What is that? ftell I am using. Observe here how I am using ftell. So immediately after opening the file, I want to know the file position. So to do that one, this will be obviously giving you some value. So I am telling the file pointer immediately after opening this file /n, and the same statement I want to print once again after using fseek. What is that one? Fseek. Okay. So what I am doing is, I have used fseek. I have read the data. I have used fseek. Now after fseek, let me check what is the file pointer. Okay. So I need to paste this one. File pointer after fseek. Okay, so here what is the value you are getting? Here what is the value you are getting? Let us check. Now immediately after, let us do this one. Let us run this program. Now it is asking enter the number of characters you want to read from the file. Let us give 7 and let us check the output. You can see the output. File pointer after fseek. We are not getting that one. File pointer. Here we have file pointer immediately after opening the file is 0. You can check there. And after that, enter number of characters you want to read from the file. Okay, let me make it more clear. Okay. Okay, now it will be, the output will be more clear to you all. See here, the output file pointer immediately after opening the file is 0 because we have used ftell and it is displaying the file pointer is now at the location of 0 for pointing to the first one. Now you are asking the user to enter the value from where you want to read the data and the number of characters you want to read from the end, 6. So if you're giving 6, then what happens? Last 6 characters will be, sorry, you'll be getting an output like this. File pointer after x6, fseek is according to the input whatever we stored in the file, it is now at the current position of 333 and the data that you got from the file is last 6 characters you have, it has been retrieved. That is how ftell can be used to retrieve the value. Got it? Suppose instead of using fseek, if you want to read the data from the last 3 characters, instead of like that, suppose you want to move from the starting location, always it should be positive value, you want to move n characters from the starting position and you want to display the value and you want to get the data till the end of the file. Okay, are you understanding what I'm doing here? Now what happens, again let us run this program. Not the end, let me give the value as 56. Then from the 56th character onwards, whatever data is there in the file that will be displayed till the end of your file. You can see there, I have given 56. That's why the file pointer has set to 56. Did you check that? Understood all of you? Now, I'll show you one more example. Instead of displaying these values and all, what I'm doing, initial file pointer I am displaying and I don't want to printf enter number to change the file pointer. Okay, I am reading that one in n and I am setting the position from 0 to n and I am displaying the file pointer. After that I am using rewind. Now what is the use of rewind? Rewind is nothing but again the file pointer will be moving to the starting location. Now let me check whether it has been moved to the after rewind. Let us run this program. There is an error. Okay, 2 Now, a file pointer immediately after opening the file is 0. Enter a number to change the file pointer. Let us give 78 as my number. That means from starting to 78th location, I want to move the file pointer. Now, if you give like this, that means you are now the file pointer should be at 78. Yes, that is what we got. Now, as we use rewind, that means the file pointer again after rewind, it has moved to 0. You can observe the difference here. We have used ftell, we have used fseek, we have used rewind. Ftell, initially we got 0 and after moving to 78th location using fseek, again the file pointer has set to 78 and we have used rewind. That means again we have gone back to again the starting location. Understood all of you? So this is how these random access file operations can be used to place your file pointer at your particular location. Right? Got it all of you? So this is how your random access file operations can be used. I hope you all are clear with this concept of how fseek can be used, how ftell can be used, how rewind can be used. According to your requirement, you can make use of these things. Now with this information, we can work with some more complicated programs. So those programs, how can we do, like copying one file contents to another file, or moving the first n characters in the file, that not moving, reversing the first n characters in the file. How these things can be done, that will start from the next class onwards. With this, all the standard library functions are over. All the standard library functions with respect to files are over. So you can start practicing all these things. Okay, I hope you all are clear with these concepts.